Dear students, this is the second video where I will explain in details how can you apply or use correlations and regression equations by using Microsoft Excel. For example, if you have two variables like age and salary, and here we have, for example, 20 people with their ages and their salaries. And we want to find if there is a correlation between age and salary. For example, if the age increases, the salary increases or not, or decreases. Here we have three types of correlation, main types of correlation: positive correlation, negative correlation, and no correlation. Let us compute the correlation here. We can use equal, correl, we choose correl function. We click on f of x. Array 1 is the age variable, for example, from 21 to 50. Array 2, the salary. And we click OK. And here the Excel program gives us the value of correlation, which is 96.48%. If we compare this value with this table, we find that we have very strong relation or correlation between age and salary. This table is explained in previous video. If, for example, the correlation value between 20 and 40, we can say that we have moderate relation or correlation. Let us here in sheet 2 correlation 2, we take three different examples. Here we have 50%, the correlation value between these two variables. 50% means a relatively strong correlation. Then we can say equal relatively strong correlation. For example, here we have the correlation value equal 8. 8 less than 10%, then equal negligible correlation. And here we have 100% means equal perfect linear relation. Let us go more in details in order to see how to create the regression equation. For example, in these cases, for this negligible, this 80%, we have a negligible relationship, then we don't need to compute the regression equation. We can compute for here and for here, for this case and for this case. For this case, we get perfect linear relationship, and for this case, we get relatively strong relationship. Let us go to this sheet where we see in Excel how to one can calculate the regression equation. And then we have in this case two variable age and salaries. Okay, let me delete this now and delete all of this. Let me calculate all of these together. Correlation value then equal correl fx. Variable 1 is the age, variable 2 is the salary. We click OK. We get 96.48%. Then we can say that we have a very strong correlation, very strong relationship. Then in this case, we can continue to find the regression equation y equal x plus b. In order to find this value, we have first to find the average, well, average of X, then average means average of age, and the same for average of Y, average of salary. After that, we have to calculate var of X. There is a function in Excel called variance. Variance of X, it then means variance of age, because in our cases, X is the age, Y is the salary. Covariance, also in Excel, we have covariance over function. It is similar to the correlation function. Array 1 is the x-axis or x or age. Y is the salary, and we get the covariance value. Now, the A value equal, as shown in this formula, equal covar value divided by var value. The B equal average of Y, this value, minus A calculated previously here, times the average of X, and we get the B. Here, after that, we have A and B, then we can say we have regression equation, Y equal X plus B, Y is the salary equal A 47 times age plus 371 is the B value. Okay. Then now we can apply this formula equal A, this is the A value, times to expect A times X plus B, this is the B, and we have here the expected value. Okay, we can fix all of this number by pressing F4 in order. F4, okay, and then we can drag and we get the regression equation line. As shown here, the red line is the regression equation line, and the blue circles are the real value. Then we can say that this regression line is nearly find the relationship between age and the salary. If you have, for example, one people with 40 years old, we can expect a salary between 2,000 2,500. Okay, thank you very much.